This large model shows a single turn of the cochlea. This large area above represents the vestibular duct. This is the vestibular membrane. This is the basilar membrane. Below the basilar membrane is the tympanic duct. In between the vestibular and basilar membranes is the cochlear duct. Sitting on the basilar membrane is the organ of Corti. You see the hair cells, and just above the hair cells is the tectoral membrane. The hair cells catch on the tectoral membrane. They bend and open up mechanically gated potassium ion channels to transduce sound. This large model of the vestibular cochlear apparatus shows the cochlea cut open. You can see the recurring turns. This would be the tympanic duct, the cochlear duct, and the vestibular duct. You see them repeating. See the cochlear part of cranial nerve 8 leading from the cochlea and joining the vestibular part of 8 coming from the vestibular apparatus. The vestibular apparatus consists of 3 semicircular canals that are at right angles to one another. The outside, of course, is bony. The interior, though, contains the membranous labyrinth. At the base of each of the semicircular canals is a swollen region called the ampulla. So each semicircular canal has only one ampulla. Inside the ampullae are the organs for rotational movement. These are the cristae with their dome-like covering called the cupula. This part of the vestibular apparatus is called the vestibule. The bone's been removed so that you can see the saccule and the utricle. Each of these 2 regions contains a patch of hair cells called a macula. So there are 2 maculae. In these regions, transduction of acceleration and deceleration and static balance is done. The 2 maculae and the 3 ampullae each have an extension of cranial nerve number 8 beginning, the vestibular part of number 8. They merge together to make the vestibular part of 8, which then bundles together with the cochlear part of 8 and proceeds then into the brainstem.